An object is composed of a number of point particles. All these point particles constitute a single object. This means that if one point particle moves, all the other point particles will also move together. There is no difference in distance between point particles. In other words, the shape of the object is fixed. If an object like this rotates about a certain axis, what is the value of its moment of inertia? Let's assume the object is located on a two-dimensional surface, or xy plane. And the axis of rotation is the z-axis. Each point particle will take its own path. However, the angular velocity of each particle is the same. That's why the shape of the object doesn't change. In cases like this, the value of the moment of inertia of the object is the sum of the moments of inertia of each point particle that makes it up. For identification, let's call them particle 1, particle 2, and particle 3. Since there are 3 point particles, and their axis is the z-axis, we can write I sub z equals I1 plus I2 plus I3. For particle 1, the mass is m1, and the distance to the axis is r1. Then the moment of inertia of particle 1 is m1 r1 squared. For particle 2, the mass is m2, and the distance to the axis is r2. Then the moment of inertia of particle 2 is m2 r2 squared. For particle 3, the mass is m3, and the distance to the shaft is r3. Then the moment of inertia of particle 3 is m3 r3 squared. Regularities like this can be written in sigma notation. This is the moment of inertia of an object composed of several point particles. Hopefully it's useful. And don't forget to watch the next video.